Okay, this is your homework question from Mentor series for inequalities. I'll start with question 8. To solve the inequality, here we have to break it down into two separate inequalities. The first one is circled in blue, and next one is in green. So starting for the one in blue, we've got 4x over 3 minus 11 is less than or equals to 3. So in order to get rid of the denominator of the 3, we can multiply throughout by a positive value of 3. And since we are multiplying by a positive number, we do not have to flip the inequality sign. This will result in 4x minus 33 is less than or equals to 9. So we have 4x is less than or equals to 33 plus 9 giving us 42. And therefore x is less than or equals to 21 over 2. So this is in blue. Now besides fulfilling what is in blue, we also need to fulfill what was in green. So 3 is less than 2x minus 5, giving us 2x is greater than 8. So x is now greater than 4. So now we have to combine both of these together. Drawing our number line, the numbers of interest will be 4 as well as 21 over 2, giving us 10.5. So 21 over 2. Now x is supposed to be less than or equal to, okay, let me use the same colors. X is supposed to be less than or equal to 21 over 2. So solid circle, indicating that we want the value of 21 over 2. And now x is greater than 4. So this one is hollow, indicating that we do not want the value of 4. So here we have our region of intersection. This being our draft working, our final answer for number line should look like this. X, 4, 21 over 2, solid circle, hollow circle, join them up. So this is the answer for part B, and the statement for this will be shown in part A. X is greater than 4 but less than or equals to 21 over 2. Take note that for the number line, we do not need to put in values 5, 6, 7, 8, 9, 10, so on and so forth. Just write down the relevant numbers. In this case will be 4 and 21 over 2. So now write down the greatest value of x, where x is a rational number. Rational numbers can be expressed as a fraction in the form a over b, where a and b are integers. So the greatest value of x for part C, part 1, answer will be 21 over 2. Then the largest value of x, where x is a prime number, in this case will be 7. Okay, now for question 9, part A, we see that x ranges from a negative number to a positive number, and y ranges from a positive 8 to positive 24, not including 24. So to find the greatest possible value of y squared minus x cubed, the greatest possible value occurs when y squared is large and x cubed is small. We are taking away a number from another number. So the largest possible value happens when y squared is as large as possible and x cubed is as small as possible. Keeping in mind that y over here ranges is only positive. It can only be positive. So the largest y squared minus x cubed must be equals to the largest y squared ever possible will be 23 squared, because we cannot have 24 as the value for y. Now I want to subtract away x cubed. What is the smallest possible value for x cubed? When we look at the range for x cubed, it ranges from negative 9 excluding until 18. So the smallest possible value will therefore be negative 8, and we cube it. this over here requires you to be aware that when you cube a negative number, you will still get a negative number. Okay, so mental sums will tell us that 8 cubed is equals to 512. Negative 8 cubed will be negative 512. Then we introduce the negative sign over here. We will make it all become positive. So 23 square minus 512 will give us 1041. One of the considerations that students may have is that, hey, what if I choose 0 as my value for x? You should be considering the value 0 when we are dealing with squares, because when we square a negative number, we still get positive. When we square a positive number, we still get positive. The smallest possible square number will be 0. Okay, so you can try putting a 0 inside here. Your answer will be 23 square, which is 23 square minus 0 cubed, leaving us with 529, which is less than 1041. Okay, so this is the answer for part A. Now part B, the least possible value occurs when the numerator is small and the denominator is big. Okay, numerator is small and then the denominator is big. This is assuming that we have a positive fraction. Okay, is it then possible to get a negative fraction? Because a negative fraction will definitely be smaller than a positive fraction. This is for the first consideration. For the second consideration will be a negative big numerator, numerator big, over denominator small. Okay, so these are the two cases that we have to consider, and then we have to decide which one is smaller. So for the first case, that is only for positive fractions. We always will try to find a negative answer because that will be smaller than positive. So let's consider, is it possible to get a negative fraction? Let's start with the denominator. The denominator is y. Now y is going to be positive. So the only chance for it to be negative is if the numerator is negative. So is it possible for the numerator to be negative? So let's take a look. When x is equals to the most negative number that we can get for an integer will be negative 8. Okay, that's in our numerator. Then I need to add this to the value of y. I want the value for y such that the numerator will be as small as possible. Okay, so in this case will be 8 divided by the value for y is 8, giving me 0. Is there anything else that could be smaller? So let's continue with negative 8 for our value for x. And now for the value of y. Suppose you try any other number, let's say 23 divided by 23. You will get a positive number. So there's no point, it is greater than 0. Okay, let's try something else. Instead of 23, let's try something slightly bigger than 8. Let's try 9. So this one is still positive. So we still are unable to get anything that is less than 0. So this must be our answer. Okay, with these considerations. So this is our answer for part B. And now for part C, the greatest multiple of 3 for x plus y. So multiple of 3 over here happens when one possibility is that x is a multiple of 3, y is also a multiple of 3. So the greatest multiple of 3 for x will be 18, plus, instead of writing 24, because 24 is not included, next one will be 21. So this gives us 39. So this one possibility, one of our considerations. Now, it is also possible that we can get a multiple of 3 if x and y are both not multiples of 3. So let's see what else is possible. X, the next smallest possible number will be 17 plus, let's say we try, okay, let's go down the line for the value of y. So let's start with 23. What plus 23 will give us a multiple of 9? So we know that if we put in 18, it will not work. If we put in 17, also will not work. If we put in 16, 16 plus 23 still gives us 39. You try for the different possibilities, you realize that the largest possible x plus y is actually 39. Okay, another way to do this is let us simply add x plus y. Okay, so since x is ranging from -9 to +8 to +18, and y is from 8 all the way until 24, we can actually combine them together. X plus y now ranges from 0 to 41. Okay, because the smallest possible value for x is -8. -8 plus 8 is 0. And then from 18 all the way to 23, we get 41. So greatest x plus y equals to 39. And now moving on to question 10. Solving the inequalities. Similar to the first question, we have to break them down into 2 parts. This is the standard way of doing it. So for the first part, in red, we've got a fraction less than another fraction. We will want to get rid of the fraction. In this case, we multiply throughout by the lowest common multiple, which is 6. Since it is a positive number, then we don't have to flip any of the signs. So for red color, we get x minus 15 less than 2 times of 7x minus 4. So x minus 15 less than 14x minus 8. Rearrange, make x the subject. Here we have 13x is greater than -15 plus 8, so -7. X is greater than -7 over 13. This is for one part of the answer. For the inequality in red, x greater than -7 over 13. And now in blue, take note now, we have to solve them at the same time. So this is an n over here. Similarly, we will now multiply throughout by 3, leaving us with 7x minus 4 less than or equals to 15 minus 18x. Again, we try to make x the subject by adding 18x on both sides. So we get 25x less than or equals to 19. X less than or equal to 19 over 25. So now we have to combine both of them together in our number line to find out, okay, what is our range? So -7 over 13 on the left, 19 over 25 on the right. We are including this value, we are excluding this value. So x ranges from -7 over 13 until 19 over 25. Take note that the smaller number on the left, the bigger number on the right. And our inequality signs will look like this. You will never see inequality signs looking like this. Okay, when x is bounded by 2 endpoints. So this one is wrong. Even if you have the equal sign, also wrong. Okay, they must face this way. Smaller number on the left, bigger number on the right. Okay, next one. draw in the boxes to help you. Let's start with the red color one. Multiplying by 2 throughout, we get 8 minus 6x less than 2x minus 3. So we add 6x to both sides, we get 8x, and we add 3 to both sides, 11. So x is greater than 11 over 8. And now in blue, we've got to multiply throughout by 6. Okay, so that leaves us with 6x minus 9 less than or equals to 2x plus 10. So I skip some steps over there. Subtracting 2x on both sides, we get 4x less than or equal to, add 9 to both sides, 19. X less than or equal to 19 over 4. Combining them together on the number line, x, smaller number on the left, in this case will be 11 over 8. Larger number on the right, 19 over 4. And add in the circles. This one is hollow, this one over here is solid. Then we have our final answer. X is greater than 11 over 8, but it's less than or equal to 19 over 4. That's for 10 part B. Now for question 11, we see that x is found inside this inequality, but there are two parts to it. So we can definitely solve this to find the range of x. And then y is found inside here. We can definitely solve this to find the range for y. So let's start with the range for x. So we made out of this, as well as this. Starting with the red color one, negative 3 less than or equal to 4x plus 1. 4x over here, subtract 1 on both sides, so negative 4. X is greater than or equal to negative 1. Okay, so flip it around, x greater than or equal to negative 1. Now in blue color, we've got 4x plus 1 less than or equal to 2x plus 9. Subtract 2x both sides, so 2x less than or equal to, subtract 1 on both sides, 8x less than or equal to 4. Number line, x must be greater than negative 1, and yet it is less than 4. So this is my range for x. And then for y, it is more straightforward. We just divide by 2 throughout. Because we are dividing by a positive number, there's no need to flip any sign. So negative 2 less than equal to y less than equal to 11 over 2. If I want the largest possible value for y, it will be 11 over 2. And now for part B. The least possible integer value for x plus 2y, x minus 2y. Okay, this one you must recognize that is the same as x square minus 2y square, which is the same as x square minus 4y square. If I want the least possible value, it occurs when I have a small number minus a big number. If possible, it's going to be negative. If possible. So I want this to be small. I want this to be huge, so that I get very small answer. Okay, now what is the smallest possible ever value for x? Square. Smallest possible value for x square. Given that we found earlier, x ranges from negative 1 to 4. If you think that smallest value of x squared occurs when x equals to negative 1, then let's try it. Equals to negative 1 square minus 4y square. But does this really give you the smallest possible value of x square? this is 1. Okay, this part over here gives us 1. What if I choose to put in a 0? Because 0 is one possible value for x. If I put in a 0, then my 0 square actually gives me 0, which is less than 1. So now I know my x value should be 0. Okay, now I want to find my largest value of 4y squared. Largest possible value for y squared. Earlier on we said that the range for y is from -2 to 11/2. If I want y squared to be huge, I will want to put in the largest numerical value for y, which in this case will be 11/2. You can consider the other extreme endpoint, which is -2, but -2 when you square you only get 4, whereas 11/2 is 10.5. You square you get about 100 over. Okay, so now I'm going to substitute this with 11/2 and I square it, giving me 0 minus, okay, so 0 minus don't need to write down, negative 4 multiplied by 1/4, which is -1/1. And this is the answer. Take note that your answer key at the back is wrong. Next, question 12. Let's find the range for x first. So, separating them in red color, -3 less than or equal to 2x plus 3. Subtract 3 on both sides. Divide by 2 on both sides. Now x is greater than or equal to -3. For the blue color one, 2x plus 3 less than 17, 2x less than 14, x less than 7. Okay, so these two must be satisfied at the same time. Therefore, our x is smaller than 7, but at the same time it is greater than or equal to -3. So we're ready for part A, the largest value of y over x. If I want this to be large, I would like it to be a positive number if possible. Possible fractions that will result in positive numbers will be positive divided by positive or negative divided by negative. Since y is only positive, I shouldn't be considering the negative values for x. So now I will want to consider only positive values for x in order to get the largest x over y. And it occurs when x is large, y is small. So I want the largest x divided by the smallest y. Therefore, largest x over y equals to large x will be 6 divided by small y, in this case 1, which is 6. Now in part B, we require x cubed plus 3y divided by y. As far as possible, it should give us a negative answer. Okay, so for part B, as far as possible, I want a negative answer. Negative fraction occurs when numerator is positive, denominator is negative, or numerator is negative divided by denominator positive. Here we have y being a positive number. Okay, so we don't have to consider this case anymore. Is there a way to get the numerator to be negative? Is there a way to get the numerator negative? Now we see x cubed. X ranges from -3 all the way until 7. So yeah, when I cube a negative number, I will get a negative number still. Negative plus a 3y. 3y is positive. Negative plus positive, it is still possible to get a negative number. So yeah, it looks like it's going to work. I want a negative value for x and find a suitable value of y divided by the same value for y to get the smallest value of x cubed plus 3y over y. Now I want a very negative number, and that occurs when my numerator is very big, denominator is very small. Keeping in mind that the fraction is still negative. So what is the smallest possible denominator? The smallest possible denominator in this case will be 1. Then when y is equals to 1, we've got plus 3 times 1. And I want a negative value for x. In this case, x could be negative 3, negative 2, negative 1. To result in the smallest value, we're going to add negative 3, and I cube it, giving me negative 27 plus 3 divided by 1. So my final answer will be negative 24. Right, so now for question 13. Solving the simultaneous equation. Let's start with the red one. Here, later on we'll do the blue one. So in red, multiplying throughout by 3 because we want to get rid of that denominator over there. Get negative 6x minus 39 less than x minus 3. Okay, so now I'm going to add 6x to both sides, leaving with negative 39 over here plus 6x, we get 7x minus 3. Now add 3 to both sides. So this gives me negative 36. I'm going to divide by 7. So negative 36 over 7 less than x. So in other words, x is greater than negative 36 over 7. And now in blue, because it is a simultaneous, we have to do them at the same time. X minus 2 less than or equal to 12 minus 3x. Okay, so let us add 3x to both sides. So we get 4x less than, and at the same time we add 2 to both sides, 14. X less than or equal to 7 over 2. Putting them on the number line, negative 36 over 7 as well as 7 over 2. It is supposed to be greater, supposed to be less. This is the required region. So final number line looks like this. This is a hollow circle. So answer will be x greater than negative 36 over 7. Y is less than or equal to 7 over 2. Then for part B, part 1, smallest integer value for x. Negative 36 over 7 is the same as negative 5 and 1 over 7. So the smallest integer value will be negative 5. For part 2, the largest rational value of x, something that is rational, can be expressed as a fraction with integers for numerator and denominator, so we get 7 over 2.